Let me introduce this ultrasonic wave and use a partial discharge tester. First, this is our test host. This is an infrared camera. This is for detecting ground electric waves. And over here is a UHF sensor. It is mainly used to test GIS. And here we have a small one. This is an ultrasound probe. And this is a flexible probe. On the back of the main unit of our instrument, there's also an ultrasonic probe. It's built in. And this is our receiver. A receiver. It's the data that we're testing through this module. And then send it to our host. And this is a wave concentrator. Let's see how to use it specifically. First, we turn on the instrument. Okay, there's a local discharge after our instrument is turned on. And sound waves. Let's first look at the sound wave side. For the sound wave, mainly uses the back of our instrument, ultrasonic probe and the camera. When we use it, we can to stick to the distribution box. It can be placed close to the distribution box or measure from a distance. Then, the mode selection here. The mode selection is active source switching, ultrasonic, gas leakage, and frequency range, time frequency diagram. This is our time frequency graph, and the right side is the frequency selection. We can record the screen here. If you need to take a photo, there is a photo button on the top. Now let's take a look at this partial discharge test. For partial discharge, there are two channels. Channel 1 is the channel of this receiver. The channel of this receiver. And our channel 2 is the channel of our filter. Let's take a look at channel 1 first. Okay, channel 1 has been successfully connected. Then you can see the channel 1 on our side, and the power of our module. When we use it, we directly stick this module to GIS. We use this distribution cabinet to demonstrate. We just stick it directly on the GIS. Then on the side, we click SAR detection. Then we can see our partial discharge here. Below is a phase diagram of partial discharge, which is the phase amplitude and time. And the top graph is it's a partial plot of the phase and amplitude. Then let's take a look at our settings. There is a threshold setting here. The threshold setting is related to, it's different according to our test. The test objects are GIS switchgear, transformers and cables. Their partial discharge alarm thresholds are different. We can set it according to our own needs. Then the detection cycle here is 1. It is the detection time, which can also be modified. On the data side, what we need to do is, first, in the first step of the detection, we need to enter the data interface first. Then here, the 3 dots above. Then create a new detection point. Then name the detection site. Then we select the switchgear we want to test. Then front, middle, and bottom. We can choose these paths according to the actual situation. For example, the cabinet number is 01. After we finish setting, click Save. Then we can see a folder here. Now we can start the inspection. We do the inspection of distribution cabinets. The main probe we use is a probe for this eye. One of it is oblique probes and an ultrasonic flexible probe. This probe is used in narrow spaces. It's our instruments and people. It's inconvenient to reach in, or in the case of electricity, which is close to, bus bars, which are close to it. And insert the probe here. When we detect, we click SAR detection. Then we can directly to the power distribution cabinet. After we finish the detection, we click to save. When we save, it will form a detection cycle. To form a detection cycle, after we save the data, after saving, it will pop up the save path of our folder. Which switchgear it is. Then we select one. Select this part we test. And then click Confirm. Now our file has been saved successfully. Now we check the data. Which is the one we just tested. And here is our data. We can export the report. This is the report we exported. And this is our report. We can also modify it here. The main thing we modify is the name, voltage level, and the factory date. We can make a simple modification. And our other probes are equipped with dedicated test lines. This test line is used to connect these probes to our receiver. And this is This is a high-frequency current transformer. Just like a current transformer, it is mainly used to detect the partial discharge of our cable. This clamp can be opened and connect the clamp to the grounding copper braid of the cable. The grounding copper braid and then this piece is our probe, which is mainly used to measure the distribution box. When we measure the distribution box, we connect it to our acquisition module. Then this is magnetic. It can be directly set on it. Then this is an infrared camera. The interface of our infrared camera is directly above our instrument. Then we insert the camera into it. When we use it, in the upper right corner of our device, there is a square on it. With a dot inside, click on this. And now this is the infrared test interface. You can also take photos here. It will also display a temperature. If we want to adjust the focal length, rotate the knob on the front of the lens, the front part of the lens. This rotation can adjust the focal length. Then we choose the appropriate focal length. It also measures the temperature. There will be a temperature display. Then on our interface, can also take photos and save them. Okay, we've taken the picture now, out of the way. Here is a photo of our infrared data. If we want to see it, in the upper right corner of the three circles, and here is the infrared, some data of the photos taken. Now let's take a look at our condenser. When we use a wave concentrator, we need to turn off this module. Now we wait for the instrument to connect. Has been connected. Then we click Start Detection here. Then we can see the partial discharge value measured by the detector. This partial discharge detector has an infrared laser aiming. We just need to aim at the part we want to measure. Then we can align a red dot with that. For example, if we want to test the top of the distribution box, we can aim the red dot at the top of that. The data saving is the same. We directly click the Save button here. After we save it, select the part we want to save and test. Click Confirm. Then we can view the data here. The data is the same as before. Then it will show a picture of a wave concentrator. The icon, we can view it. It can also export reports. Then we have channel 1 and channel 2. There are two channels that can be used simultaneously. When we use them simultaneously, we need to wait for a while. Let the two detection modules, that is, our waveguide and our receiving module, it may take a minute to connect them both. Okay, here we go. Both channels are connected. Then we click Start Test here. Both channels are tested simultaneously. And then we save it in the same way. And here's what we just tested. The data of both channels is in it. If we need to check it, we can click in directly. On the side of our instrument, there is a charging port and charging interface, USB interface and network interface. This interface is mainly for our network port and USB port, mainly used for us to export data for use. Okay, that's all for the introduction of the instrument.